The first thing you need to do to graph a quadratic inequality is find the zeros or the solutions or the x-intercepts of your quadratic. There's a number of ways you could do that. You could try factoring, you could try quadratic formula, you could try complete the square. This is a relatively easy one to factor, so we'll factor this real quick. Two numbers that multiply to negative 12 but add up to negative 4 are negative 6 and positive 2. So I can factor this into x minus 6 and x minus 2, or x plus 2, sorry. Notice I was already, well, not equal to 0, but I had this set with 0 on the other side. We always want to have that be the case. Which means my two solutions then, my two x-intercepts, are x equals positive 6 and x equals negative 2. I could have found the same thing if I used the quadratic formula, and if you have the program, I'd go ahead and recommend you try that real quick and just make sure that yes, those are in fact your two x-intercepts. What I'm going to do now is I'm going to graph these two x-intercepts on a number line. Really, this is just the x-axis. What makes these problems kind of confusing is we're not graphing two-dimensionally. I'm just going to graph in one dimension on this number line. So let's put our two x-intercepts on this. Think of it as the x-axis. I'm going to use a filled in circle because in this case I could be equal to 0. So I'll have two filled in circles. And then what I want to do is I want to imagine what the parabola would look like if I actually graphed it. So I want to imagine I had like a y-axis right here. So I want to see what the parabola would look like. Well, I know this parabola opens upwards because my a value is positive. So I know my parabola looks something like this. It would cross, hit those two, hit the x-axis at those two values, and then go back up. So that's roughly what my parabola would look like. Well, what I'm going to do now to finish the inequality part of this is I'm going to shade a portion of my number line. I'm either going to shade the end intervals, those pieces, or I'm going to shade in between. And to do this, I have to go back and look at what my inequality was asking me for. They asked me to find where this was less than 0. In other words, they want me to shade where the parabola is below less than the x-axis. And so what I'm going to do is I'm going to pretend that I'm standing somewhere on the x-axis and see if the parabola is above or below me. For example, if I'm standing over here, look, there's me. The parabola is up above me, so I don't want to shade that section. If I were to stand at the other end, once again, the parabola is going to be up above me. I don't want to shade that section. However, if I were to stand in between these 2 points and try to find where the parabola is located, well, the parabola is located below me. That's the section I want because it said to shade where my parabola is below the x-axis. So what I'll do is I'll cut myself in half right there, I suppose, and shade those points, or shade that interval in between those two x-intercepts. So my solution is really just this number line. The parabola is not part of it. I know I got a little messy here, but the solution is just this number line. If I want to write my answer in interval notation, I can go ahead and do that. The smallest interval, the smallest number on this interval is negative 2. And because I'm allowed to be equal to negative 2, I can use a bracket. The interval goes all the way to positive 6. And once again, I can be equal to positive 6. So there's my answer in interval notation for where this parabola is less than or equal to 0. And let's take a look at one more example of a quadratic inequality. This time I'm not not really equal to 0, but I don't have 0 on one side of my inequality. So what I'll want to do is I want to move everything to one side, so that one side is 0. So I'll subtract the x, I'll subtract the 10, and then this whole thing is now less than 0. I don't need to switch the symbol because I didn't divide by anything negative. So here's the inequality I want to graph. First thing is I'll need to again find the two x-intercepts. I could do that by factoring, I could use the quadratic formula. For time, I'm going to use the quadratic formula, and I've really already done that. And I know my two answers come out to be negative 2 and 2.5. If you want to pause the video and confirm that by doing the quadratic formula, I'd go ahead and do that right now. So let's get those two values graphed on the number line. Those two values are where the parabola would be equal to 0. So let's get those, that's where it would hit the x-axis. So negative 2 and 2.5. This time I have an open circle because I'm not allowed to be equal to 0. This time I just want to know where is the parabola, again, less than 0. When is it below the x-axis again? Okay, so what's helpful for me to do is to draw in the parabola and see what it would look like. Once again, I have a positive a value, so my parabola will open upwards. So I like to sketch this on the number line, although you don't need to if you can just visualize it. But my parabola would look something like this since it opens upwards. it would cross the x-axis or the number line at those two values we found. Once again, I want to find the interval where the parabola is below the x-axis. So if you imagine standing here in between the 2 points and look for where the parabola is located, it's located below you. That's the section I want. So once again, I'm going to end up shading the section in between the 2 points. That's where the parabola is less than 0 or below the x-axis. To write your answer in interval notation, very similar to last time. The big difference is because I cannot be equal to -2, I can just get really close to it. I need to use parentheses, but my interval is between -2 and 2.5.